live on a small, watery rock, orbiting a mediocre star in a quiet suburb of a vast galaxy. For millennia, we have looked up and wondered, are we alone? Logic suggests we shouldn't be. The numbers dictate that the universe should be teeming with life, cacophonous with alien civilizations. Yet, when we turn our instruments to the stars, we hear only static, a screaming, infinite silence. This disconnection between what should be and what is the most profound mystery in science. The lunchtime revelation. It began not in an observatory, but at a lunch table. In 1950, at Los Alamos, the brilliant physicist Enrico Fermi was dining with colleagues. They were casually discussing recent UFO reports, dismissing them as nonsense, naturally. But Fermi, whose mind worked like a calculating engine, suddenly fell silent. He ran some rough numbers in his head, the number of stars, the age of the galaxy, the probability of life. He suddenly looked up and dropped the question that would haunt astronomy for decades. But where is everybody? It seems simple, but it was revolutionary. Fermi realized that the Earth is young compared to the universe. If interstellar travel is possible, even at slow speeds, the galaxy, being over 13 billion years old, should have been colonized long ago. Even just one civilization, expanding slowly, could populate the entire Milky Way in a few million years, a cosmic blink of an eye. If they existed, their footprints should be everywhere. We should see their megastructures, hear their communications, or have already been visited. The fact that we haven't isn't just odd, it's terrifying. It suggests that our understanding of life, the universe, or intelligence itself is fundamentally flawed. This is the core of the Fermi Paradox. The tyranny of numbers, the Drake equation. To understand why Fermi's question is so potent, we must grasp the scale of the theatre. Our star, the Sun, is one of roughly 200 to 400 billion stars in the Milky Way alone. And the Milky Way is just one of maybe 2 trillion galaxies in the observable universe. The numbers are beyond human comprehension. In 1961, astronomer Frank Drake attempted to quantify this with the famous Drake equation. It's not a rigorous mathematical formula meant to be solved, but rather a framework for our ignorance. It multiplies several variables: the rate of star formation, the fraction of those stars with planets, the number of planets that could support life, the fraction where life actually begins, where that life becomes intelligent, and finally, where that intelligence develops technology that releases detectable signals. We now know, thanks to missions like the Kepler Space Telescope, that planets are common. Rocky, Earth-sized planets in habitable zones are likely everywhere. The first few variables of the equation are looking optimistic. The sheer volume of real estate in the cosmos dictates that we should be drowning in company. If even a fraction of a percent of these worlds develop advanced civilizations, there should be millions in our galaxy alone. So, why the silence? The Drake equation doesn't give us the answer. It only highlights the massive gaping hole in our data regarding the emergence of intelligence. Deep time and the cosmic calendar. Space is vast, but time is even vaster. This is the dimension that truly gives the Fermi Paradox its teeth. The universe is approximately 13.8 billion years old. The Earth is about 4.5 billion years old. We, as a technological species capable of radio astronomy, have existed for roughly 100 years. Imagine the history of the universe compressed into a single calendar year. The Big Bang is January 1st at midnight. Our solar system doesn't even form until early September. Complex life on Earth arrives in December. The dinosaurs go extinct on December 26th. Modern humans? We don't show up until the last few minutes of December 31st. Your entire life, all recorded history, happens in the final second before the New Year ball drops. Why does this matter? because it means other potential civilizations could have had a head start on us, not of millions, but billions of years. Imagine a society that was at our current technological level when Earth was still a molten ball of magma. Where would they be now? Their technology would be indistinguishable from magic to us. They would have had ample time to reshape their solar system, perhaps even the galaxy. The silence suggests that either nobody survives that long, or we are the very first to arrive at the party. The Great Filter, Part 1, behind us. If the stage is set and the time is ample, then something must be stopping life from reaching the space-faring civilization stage. Scientists call this theoretical barrier the Great Filter. It is a step in the evolutionary ladder that is incredibly improbable or impossible to overcome. The crucial question for humanity is, where is the filter located? One optimistic possibility is that the filter is behind us. We have already passed the hardest test. This scenario suggests that life itself is incredibly rare. Perhaps the leap from non-living chemistry to the first self-replicating organism, abiogenesis, is a near miracle that has happened only a handful of times in the universe. Or maybe simple life is common, but complex life is rare. For billions of years, Earth was inhabited only by single-celled organisms. The leap to complex eukaryotic cells, cells with a nucleus, took a massive amount of time and might be a freak accident of biology. Furthermore, the evolution of high intelligence, tool use, and technological capability might be incredibly specific to Earth's unique environment. If the Great Filter is behind us, it means we are special. We are the winners of a cosmic lottery, uniquely positioned to inherit the galaxy. It's a lonely thought, but a hopeful one. The Great Filter, Part 2, ahead of us. There is a darker alternative. What if life arises easily? Intelligence evolves frequently, but the Great Filter lies ahead of us. This hypothesis suggests that all civilizations, upon reaching a certain level of technological power, inevitably destroy themselves. We are already seeing the potential mechanisms for our own demise. We discovered nuclear energy and immediately built enough weapons to sterilize the planet. We are altering our climate at an unprecedented rate. We are on the verge of creating artificial intelligence whose goals might not align with our survival. If the filter is ahead, it means that throughout the cosmos, civilizations flare up like matches in the dark, achieving radio technology for a few centuries before succumbing to war, ecological collapse, or technological catastrophe. The silence we hear is not an empty universe, but a cosmic graveyard. It means that the odds of humanity becoming an interstellar species are statistically near zero, and we are fast approaching our own expiration date. The Silence of the Spheres, SETI. For over 60 years, we haven't just been wondering, we've been listening. The search for extraterrestrial intelligence, or SETI, has been scanning the skies for telltale signs of technology. We look for narrow-band radio signals that couldn't be produced by natural cosmic phenomena, a beacon, or perhaps leaked transmissions from an alien TV broadcast. We've had tantalizing moments. In 1977, the WOW signal was detected, a strong narrowband radio burst that bore all the hallmarks of an artificial source. It lasted 72 seconds and never repeated. To this day, it remains unexplained. But aside from that, we have found nothing. However, our silence might be due to our impatience. We have only been listening for a few decades, and we've only scanned a tiny fraction of the sky across limited frequencies. Furthermore, our own radio leakage is getting quieter as we switch to fiber optics and digital transmissions. An advanced civilization might only be loud in the radio spectrum for a century or two before going silent again. Searching for them is like scooping a cup of water from the ocean and finding no fish, declaring the ocean empty. We may just need a bigger net. Type Explorers, the Kardashev scale. When we look for aliens, we tend to imagine beings like us, only slightly more advanced. But Russian astrophysicist Nikolai Kardashev proposed a scale that suggests we should be looking for something far grander. The Kardashev scale measures a civilization's advancement by its energy consumption. A Type 1 civilization can harness all the energy falling on its home planet from its star. Humanity is currently about a Type 0.7. A Type 2 civilization can harness the total energy output of its entire star. This would require mega-engineering projects like a Dyson sphere, a massive shell constructed around a star to capture every photon of energy. A Type 3 civilization controls the energy of its entire galaxy. If such civilizations existed, they wouldn't be subtle. A Dyson sphere would alter the light signature of its star in detectable ways. A Type 3 civilization would remake its galaxy, perhaps darkening entire arms of the Milky Way as they harvest stars for fuel. The fact that we look out and see a natural galaxy, untouched by massive geoengineering, is strong evidence that no Type 3 and perhaps no Type 2 civilizations currently exist near us. The zoo, hypothesis, and quarantine. There are solutions to the paradox that don't involve humanity being alone or doomed. What if they are here, but they are hiding? This is known as the zoo hypothesis. Just as we set aside nature reserves and observe wildlife without interfering, advanced civilizations might treat Earth as a protected zone. They may have a prime directive, a strict non-interference policy for developing societies. They could be observing us right now with technology so advanced it's undetectable, watching our wars and our art like a cosmic reality TV show or a scientific study. Alternatively, they might be enforcing a quarantine. Perhaps we are viewed as dangerous, a violent, unstable species that hasn't mastered its own aggressive tendencies before unlocking nuclear power. They might be waiting to see if we destroy ourselves or mature into a peaceful species before they hand us the keys to the interstellar neighborhood. In this scenario, the silence isn't emptiness. It's a deliberate isolation imposed by the grown-ups in the room. Alternative realities and dimensional shifts. Our search assumes that advanced intelligence remains biological and interested in physical space. This might be a naive assumption. We are already merging with our technology. An exponentially more advanced society might have abandoned biology entirely, uploading their consciousness into vast digital substrates. Why travel in fragile metal tin cans across the deadly void of space when you can exist in a simulated paradise where you control the laws of physics? They might be right here, living in digital universes running on computers powered by harvested stars, completely uninterested in the physical reality we inhabit. Furthermore, our understanding of physics is incomplete. We only perceive roughly 5% of the universe. The rest is dark matter and dark energy. Perhaps advanced civilizations utilize physics we haven't discovered yet, operating in higher dimensions or communicating via mediums like gravitational waves or neutrino bursts that we are only just learning to detect. They might be shouting at us, but we are still trying to listen with smoke signals. The final reflection. The Fermi Paradox offers no easy answers, only a mirror reflecting our own existential anxieties. The solutions range from the incredibly hopeful, we are the first chosen ones, to the incredibly bleak, we are doomed to self-destruction. Regardless of the truth, the silence itself carries a profound message. If we are alone, the responsibility resting on human shoulders is immense. We are the only custodians of consciousness, the only known way for the universe to experience itself. If we destroy ourselves, this corner of the cosmos goes dark forever. If we are not alone, it means we have a potential future among the stars, a destiny greater than just this one planet. The silence demands that we survive. It demands that we become better stewards of our world and each other, so that one day, if we finally do receive that call from the stars, there will be someone here left to answer it.